Okay, so here are the slides for this week. Again, like I said, I'm going to be just splitting the hypothesis testing up into two parts. I'll post the rest of it tomorrow. But this is what I'm going to do from now on is just have what week we're in, and then obviously we have 5 weeks in the semester, just to kind of keep us on track. Days at this point aren't gonna be as helpful. Anyway, I think the logic of this thing is going to be pretty straightforward. I think you're not going to have any issue with the concept and the idea of how things work in general, the big picture stuff. The math can be a little thorny, I'll be honest with you, but that's why I wanted to kind of take it in steps and do sort of. I think of this chapter as kind of having 4 pieces. I want to do 2 of them today and then 2 tomorrow, and make sure I'm working out examples. So to begin, imagine, well, you don't have to imagine, but I don't know if some of you have noticed, but gas prices have been declining pretty steadily over the last about a month and a half for various reasons. The national average today is under $2, and it's been a long time since I can remember that. I think in Georgia we're even lower than that, yeah. Just an aside, I always think it's funny how gas stations are I think that's the only business where they can charge a percentage of a cent. So, you'll see oftentimes like, $1.99 and 9/10 of a cent. I can't think of any other business that does that. That's always been kind of weird to me. But anyway, the book uses gas prices as an example, and I think it's a good one, to kind of launch with. So imagine that we're looking at gas prices in the United States. So we're looking at the mean price of gas in, say, Georgia versus the national mean. So I won't flip back to it, but it was a little bit lower in Georgia. You can imagine in states like California, it's probably higher than the national average. So that's going to be an example I kind of allude back to throughout each of these, today's lesson and tomorrow's. It's also used in the book, so just to kind of ground us. So the essence of what we're talking about today is that we need some kind of procedure to allow us to evaluate hypotheses about a population based on sample statistics. We're finally entering the core of inferential statistics now. So think back to chapter 7 with the estimation. So in chapter 7, we estimated population parameters using the sample statistics, right? So we're using sample statistics to say, what is our estimate for a population mean or proportion given a standard error, right? So like looking at like confidence intervals. So using statistics to make estimates of population parameters. The difference in what we're doing today is that we're looking, so chapter 8, which is the hypothesis testing chapter. Actually, I'm sorry, I should go ahead and change that. Chapter 8 was your estimation, and chapter 9 was your hypothesis. Pardon me on that. So anyway, yeah, so today when we're looking at testing hypotheses, we're going to use sample statistics to make decisions about population parameters. So it's a little bit different. Hopefully you're able to see the difference there, that rather than using the statistics to estimate the parameters, here we're using statistics to make decisions about the population parameters. Are they accurate? Can we expect those within a degree of confidence? Okay, so that's the procedure that allows us to do such as the statistical hypothesis testing. And like I said, there's 4 pieces. Today we're going to do 2. The most basic is what we're going to do first. And just, I guess to begin, every one of these pieces is going to have similar to these 5 essential steps. Some will add like little different nuances, but basically what you're going to have is every time you do a hypothesis test, you're going to go through these 5 steps. The first is you have to make assumptions. This is typically given to you. I'll work through each of these here in a second, but the assumptions are something that if the data is not collected randomly, that's one. Obviously, we can't do hypothesis testing. Your second is going to be stating the null and research hypothesis, so actually outlining what they are, and then selecting an alpha, which is sort of like your cutoff level. And then you'll select the sample distribution. So today we're going to look at Z's, the Z table, but also T, the T distribution. I'm going to introduce that later. So you're going to have to know which sampling distribution to use and specify the test statistic, meaning you'll calculate a Z score or a T statistic. Simple. And then in part 4, once you specify what you'll use, the fourth step is actually computing the test statistic. And then after you compute the test statistic, you can make a decision of your hypotheses based on the results. So either you'll reject the null or fail to reject the null. We'll go through each of these in a sec. So here we are in part 1. So the first, and this is usually something that's given to you, but don't overlook it. I've often thought I could throw you a curveball and do something where I give you data that's not randomly selected and you wouldn't be able to do the hypothesis testing, and that would be kind of a way to make sure that you're paying attention to the assumptions. But in general, these are going to be given to you. So the assumptions that we make in order to do hypothesis testing, the sample has to be randomly selected, period. Really, to do any inferential statistics, if the sample's not randomly selected, we can't infer anything about the population based on that sample because it's not representative, obviously. Number 2 is that the variable must be measured at the interval ratio level. We don't use this for nominal variables or ordinal variables. We have other techniques that we'll use for those, and we'll get to those in subsequent chapters. And then lastly, a sufficiently large sample size. Greater than 50 is a general rule. So hopefully that's ringing some bells. That's the central limit theorem idea. So you have to have a sample that's large enough, randomly selected, and measured at the interval ratio variable in order to do statistical hypothesis testing. So those are our basic assumptions. Okay, so the first thing you want to do is state the research and null hypothesis. So what we're talking about here is we're always looking at an interrelation between two variables, so x and y. So x causes y, or in the lingo you've probably seen before, like an independent variable causes a dependent variable. So we're always looking at the relationship between two variables. And these relationships that we develop and the null and research hypothesis is a place where theory and stats meet. As we get to this stuff here, as we get to the actual, practicing the examples here in a second, you'll see that our hypotheses they should be driven by theory, by concepts, by sociological ideas. You shouldn't just be picking, two variables and guessing that they're related out of randomness. Clearly, they should have some kind of link. So, something as simple as, poverty level being linked to, something like dietary quality. So, things that are based on actual ideas. So I always like to kind of state the points where stats and theory meet. Here's one of them. In where you develop your hypotheses, they should be theoretically driven. Okay, so the research hypothesis is always, here it is right here. The research hypothesis is always denoted as H sub 1. And your research hypothesis is a statement reflecting the substantive hypothesis that is expressed in terms of population parameters, the key part, but its specific form varies from test to test. The key is that we're always looking for the relationship between parameters. So as you see down here, we're always looking for, we wouldn't want to look at X bar equal to something, the sample mean. We want to know something about the population mean, mu. So in general, the research hypothesis follows one of the one of these kind of general formats, that it's not equal to some value, so mu is not equal to some specific value, that it's greater than some value, or that it's less than some value. How do we decide which? Well, again, that's theoretically driven. We know how things work in the social world, so we'd expect some, we would determine whether we're looking for something being greater or less than based on, what we know. So something like comparing men's and women's income, we know that women tend to make less for doing the same job. So we would want to do a less than specified value. So again, it's theoretically driven. The key is, though, that the research hypothesis is always in terms of the population parameters, and it's always set up as this H sub 1. So kind of going back to this a little bit, the not equal, greater than, or less than, what it really means is we can perform what's called a one-tailed test or a two-tailed test. So here we're just talking about all the one-tailed test types. So a one-tailed test is a type of hypothesis test that involves a directional research hypothesis. So obviously a right tail would be greater than some specified value. A left tail would be less than. We only use a one-tailed test if we have a theoretical reason to believe that one value would be less than the other. Like the sex differences in income would be, like I just gave, would be an example of that. If we don't have any theoretical reason to believe that one might be less than the other, then we would just do what's called a two-tailed test. So this is where we just test whether the population mean is not equal to some specified value. So we're only testing differences here, not direction. And in the examples, I'll typically specify whether I want you to perform a one or two-tailed test. But just know that the way that researchers do this is it's theoretically driven. If you have a reason to believe that it might be less or more, then you would do the one-tailed. But unless you do, typically a two-tailed test is kind of your you see this more kind of in day-to-day kind of stuff. Okay. So the research hypothesis is always denoted H sub 1. Okay. The null hypothesis is always denoted H sub 0. And it indicates that mu is equal to some specified value. So the null hypothesis is a statement of no difference that contradicts the research hypothesis, is always expressed in the, again, it's in population parameters. We're always talking about mu, the population mean. Or later in part 2, when we get to population proportions, we're looking at the population number. We're not looking at the sample in and of itself. We use the sample statistics to make conclusions about the population. So ultimately what the hypotheses are about the population. Okay, so the null hypothesis is basically kind of like what it sounds like. It's the hypothesis that there is no difference between two means or between two, between a sample mean and a population mean. So it basically tells us that, it states that there's not a difference in the values. Whereas the research hypothesis is that there is a difference, whether it's greater than, less than, which is one tail, or not equal to, which is a two tail. Either way, when you do hypothesis testing, you always have this contrast between H sub 1 and H sub 0 as your research and null hypothesis. And kind of how I like to think about this is sort of like how courts, the criminal justice system. So in the United States, in most democracies, you have this presumption of innocence until proven guilty. So I kind of think I think that's a good analogy for what the research and null hypothesis is. We assume the null hypothesis. So think of the null hypothesis as innocence. We assume there's no relationship until we can prove that there is a relationship.